Welcome to a new test and teardown video. This time it's a regulated power supply from Oltronix. And this one is the type LS115. I believe there's like quite a lot of different models. They're looking more or less the same kind of weights, the same kind of layout, and the same kind of, depending on how many volts and amps and all that kind of stuff they can do, they're a little bit bigger or smaller. And I believe this one is probably the biggest one. I was able to find a schematic on a radiomuseum about the LS15, and that reminds me very much of this one. I mean, it's 99% that one, from specifications and from all the internals and stuff like that. So I think that more or less I got the right schematic. At least that is what I feel so far. They had a bunch of these at a local school, and somebody figured out, ooh, this one contains a lot of EL34s, and that is right. 5 of them in each of the power supply, and they had a whole pallet of them to throw out. So somebody stole all the output power pentodes. So first of all, I can't power this up. I need to open it first and do a little quick inspection. But before I do that, let's check out the specifications here. So we got the instrument switch that can do, so that is voltage in 2 levels, and then 500 milliamps, 500 volts, man. And then you can select the output voltage range from 240 to 500, or from 0 to 240 volts. And then you have one dial for 0 to 500. You also got another one, 0 to 150, but that is only a potentiometer, as you can see here on the front. And it'll also say the output impedance of that voltage, and it is a negative voltage. And they are connected together to a common 0. And this one is the chassis. If you disconnect this one, you should be able to see the chassis symbol. And the reason why you can disconnect this from the chassis, that is of course if you've got 2 of those and you want to connect them in series, or you want to do a plus minus supply or whatever you want to do. So that is why you need to be able to disconnect the 0 from the chassis. And then you got 2 outputs for filaments, a 2 amp and a 6 amp, 6.3 volts. The reason for this is so you can put them in series for 12 volts. So this is very useful. And of course, if you're running in serious mode, you don't need more than 2 amps anyway, so that's pretty fine. So yeah, let's do a quick inspection. So while I was going to take it to pieces, I thought, yeah, well, why not measure its weight? It's very close to 14 kilograms. Wow, that is a heavy unit. So yeah, this is the mains input that you can turn on and off. Let me see if I can do this. That switch here on the front, that is of course the DC output. And by the way, I believe this one turns on and off all the outputs, or all the DC, and it's not turning off the filaments. So that's perfectly safe to work on. So now I'm inside. This is a very beautiful power supply. Let me show you here. So yes, I was right about the 5 EL34s. Luckily, all the other tubes, they're still here. And of course, they're not that interesting to score anyway. I've been inspecting a little bit down here and trying to clean up a little bit on the top of those capacitors, just to see if they're a little bit slimy. If you see that one here in the middle of the picture, it looks a little bit wet up here, so that is why I tried to clean that one. And then I'm doing all my visual here and seeking where's the stuff that prevents me from powering this up. This capacitor here. This is kind of a normal thing that they look like this. It's not always a leak, but definitely it's not new anymore. I believe this one is from around 1960. Let's try and look at the other side. Oh man, that is a big power. Oh man, this transformer is so big. I mean, here's my hand. I don't know. It is very, very big. And all those capacitors. And I actually did wipe away some white nastiness from that one. But I believe they're more or less all in parallel, or at least those and those are alright. So that will be okay. I got a... Oh, look at all the rust here. So it was stored in somebody's humid shack. So this is a little bit bad. It's a little bit funny to see all those fuses. They corrode with this green stuff, and I believe this has something to do with the nickel plating that they're all made of. So they always look like that. And that is a relay that is driven by the filaments, or in parallel with the filaments, so that will always be on. So that means immediately when you disconnect mains, it will pull off, or it will release the relay, and it will remove all the high voltage. So because you can imagine that the cool down of everything here, the regulation and all that kind of stuff, will of course cause the EL34s to go to maximum, and you don't want that, right? So that is a nice safety feature for against that. And then we got all the UL84, UF, and UL. So that's a high voltage filament system, and the EL34 they're running on a low voltage filament. So it's a little bit complex. I don't know exactly why they're doing that. And here is a 85A2, so this is a little bit special. A regulator tube for a local high voltage, right? If I'm not completely mistaken. But I think we should try and clean it up a little bit, because this is a little bit too dirty to work on. So now I've just cleaned it a little bit. Just dusted it a little bit. And now we are looking at the other side. And here's the tube I was talking about before, and that is just a voltage regulator tube, and it's super easy to identify them, because they're like really dark. And you see, only 2 wires to them. Sometimes you see some more wires going through them, and that's actually just because they're using the other shorted pins as an on-off feature. That means if you disconnect the tube, then nothing bad's gonna happen, because it's like a Zener diode, right? But still, I'm not able to find anything that prevents me from going any further. So yeah, I am definitely going to power it up. I only think those 2 there looks a little bit slimy. But if they did leak a lot, I mean... Ooh, yes, that is exactly what I was looking for. I was about to say, yeah, if they leaked a lot, I should be able to see the leaked slime on the wires. And that, ladies and gentlemen, is that leaked slime from those capacitors, and they do look a little bit wetty. Oh no, man. And it's not super easy to get in there. And by the way, this slime here is conductive, so I should expect a lot of ripple and unstable behavior. And that one, those 2, yes, see, down there at the bottom. See? You can also see the slimy leak. So how on earth am I going in there to replace this? Aha! If I remove those tubes, I can tilt down the entire front panel. So it is possible to service this. Maybe I should do that, but I did go and pick up some EL34s. So those, they're going in this unit in a few minutes. That is a beautiful sight. With all the tubes in. So let's see what's gonna happen. Let's try and power this up and see what happens. We are measuring the output and DC is on. I picked the low range just because I'm a baby boy. And we turn this on. Turn on mains, and then I'm gonna crank on with my vario real nice and slowly while we monitor the usage. I can definitely hear. Let's turn off the light here. Can you hear that? This is the relay, and this is at 90 volts AC, so we should just go straight through that. It is only 25 watts, so let's just give it a little bit more. 200. Yeah, see, then it's 200 watts of idle and it's warming up, and then I crank it all the way 220. I am ready to turn it off here. So this is the output voltage. It is definitely doing its thing correctly because I am at minimum voltage here, right? So that is good. Let's try and... Why is that not happening? Okay, so we we don't have a regulation here. So DC is on. No, that is not on. So that is not helping me at all. So what if I go to the highest voltage and then I don't see anything as well? No luck with anything here, and I got light in all the lamps. More or less, I would say, well, it's using 100 watts at the moment. But definitely it's not working. So far so good. All I had to do was move a little bit in some of the sockets. Look at that! It is now powered up again. I am now in the high range. And look at the voltage here, so that is 300. And even the meter is more or less accurate. Let's see if it goes down to 200 and... Oh, it even goes lower than the claimed 240. It's probably gonna go all the way to 500. A little more even. Oh, don't you just love it? Love it, love it. Wow, man. What a happy camper. So it really, really works. And this is 1960. And there was actually one more thing that we need to check. And that is the negative. Ooh, negative. Okay. Haha. Well, that's funny. So this potmeter here, the potentiometer here is not connected. See? That is an easy thing to fix, right? Ah, no, it's me who's an idiot. Look at this. Oh, you can't see the symbol. Here is minus 150. But here in the middle is a variable output. Oh, that is how it works. So that is not defective at all. How cool is that? This is a little bit sticky, just need a little bit more massage. But that is really nice with this negative voltage. Ooh, hoo, hoo. Can hear the hum from the transformer. Oh my gosh. Can I flip this one when I am okay. So maybe I should turn off the output. Ah, see, exactly. That one turns off both of the outputs. So that means it is now safe and fine to go to the low range. And then, ooh, there's leak. Look at that, we still got, there's a capacitor on the output, see? Just a tiny little one, because there's very, very high input impedance in the meter like that. So I should be able to flip the switch like that, and then I got the other one is from 0 to 240, so that is 250, and then we can go down to probably 0. It goes to 0, man. That is a nice power supply. 500 milliamps and 500 volts. Oh man, what are we going to melt down with this one? But that is very, very useful. Now I'm a little bit sad that I just ordered a new one. Oh no, why did I do that?
Are you wasting money, honey?
Yeah, man, because this one actually works.
Oh, no.
And this is also 500 volts and all that, those amps and shit. So why the... Yeah. Can I really want to flip this one when it's out. So, when it is on. But that works too. Of course you can do that. That is a nice power supply. I am really, really happy. And it's only using 108 watts. And the noise, this hum is loud. So this is 108 watts. It actually works. But of course, let's look with a scope and see how well it really is. When you power up tube regulated power supplies, always be aware of the power on sequence, and that is why they have this DC on, or this output enable switch. So always be sure this is off, because look at the voltmeter here, it is in 500 volt, and I adjusted the output for 200. So now we'll crank on the mains and let's see what happens. So the voltmeter is connected. Ooh, 400. And then the regulation circuits warm up and they will get stable and they will measure the voltage and they will start to regulate and do their thing. And then after a little while, we should get the 200. Here we go. So this is the power on sequence of a tube regulated power supply. And you can imagine if you adjusted something for 200 and you're playing around with some electronics that can only handle 200, it's going to blow up by 400, right? And you forgot the output enable. So that meter is before the output enable, but there's actually a little bit of leak, I think. Let's have a look. No, there's not. So here's the output. It is 0. And of course, if I turn it on, it's going to go straight to 200. Fantastic. So far, so good. See, when I turn it off, it goes super slowly down. So, yeah. So it's not my load that is doing this. It's in here. Yep. So here's the schematic of the Oltronix power supply LS15. So this is very, very close to the power supply I got. I got the 115, and as far as I've been able to see, the difference is in this pre-regulator, the UBL21. I don't have that part. I got a some other tube there, but anyway, it's more or less the same principle of this schematic with the 5 EL34s in parallel. I think it's a little bit funny to see how the grids there are connected with the 240 ohms and all that. I think they did this just because that was easy or something like that. And then you got, of course, the two tubes at the bottom here that's doing the voltage regulation and the feedback and all that kind of stuff. So now I'm going for a little benchmark testing. So here's my little 1 kilovolt load, and that should be able to load this thing. So I'm just running at 200 volts. It's actually because I don't want to overload my probe and my scope. So now we're in a ripple here, and then I'll try and pull a little bit of current. So this is, let's just start with 100 milliamps. So this is nice and easy. This is only 20 watts. Let's just see how this amp meter is working. So if this is a 102 milliamps, look at that. So the meter is actually accurate. And we're running at 200 volts, so I should be able to, yep. But I don't see any ripple. And this is 20 millivolts per division. Wow, man. That is really nice. So it is definitely working. There's the leak from those capacitors is just not of any effect to its performance, because it's regulating and it's stable and all is good. How about we try some load dump? So that means I go into normal mode and I set up my trigger like that, right? And then I turn off my load. Spit down. Okay. Let's try it. Yeah, obviously. So here's your load dump. But this is 200 millivolts per division. That is not too bad. And this is 200 volts of output. And it's only, yeah, okay, so this is 400 millivolts of output. And then it goes into regulation again. Let's see how it goes with, see? That is not bad. Not bad at all. Wow, man. The only thing I'm a little bit worried about is the size and the 14 kilos. Oh yeah, so this is very convenient with the watts here. So this is 20 watts and this is 0 watts. Okay, so see how it is. Oh, let me turn off the light here. Look at the input power. So this is my idle 108, and let's load it 20 watts, and now it's 152. And this is of course because we got a lot of voltage over the series regulators. All those beautiful tubes, they are running with a lot of voltage across them, and that is why we are burning all this power in anode loss. But that is just how it is when you make a linear power supply with tubes. It's going to warm up something. And that is okay. I kind of like it though. Anyway, I just wanted to say thank you very much for watching. I hope you enjoyed the video. Please like and subscribe.